Okay, good morning, good afternoon, good night, whatever it might be. Let's talk about naming alkenes. It's very similar to alkanes. Okay, the same type of procedure that we use to name alkanes, we're going to use to name alkenes with just a few slight adjustments. So the first thing we got to do is treat the alkene as a functional group. That means it's going to get priority over substituents. Okay? And because it's a functional group, in the name we replace the normal ANE with ENE. So alkane versus alkene. Example, this is propane, 1, 2, 3 carbons. If we add a double bond in there, we drop the ANE and put ENE for propene. Okay? As our structure gets bigger, our naming gets a little bit more complicated. So we have to use a number to indicate the position of the double bond if needed. For example, here, okay, if we number this 4-carbon alkene, we put number 1 on the left, 1, 2, 3, 4. We want to give our functional group the lowest priority we can. Since our double bond starts at carbon number 1, we indicate that here, 1-butene. However, if the double bond were here, we would say 1, 2, 3, 4. The double bond starts at carbon number 2, and it's 2-butene. So stop this at any time. Stop it at any time. It probably is a good idea if I draw a structure before I name it. You can pause the video and try and name it yourself. But let's keep going now. So our longest chain, just like Chapter 3, when we're naming, we find our longest continuous chain. Our longest chain with alkenes must include the double bond. Okay? Longest chain must include the double bond. Example. Let's look at this alkene. If I were to name this and all you remembered was to find the longest chain, you would say 1, 2, 3, 4, 5, 6, 7, 8. Okay, but that longest chain does not include the entire double bond. So it's no good. It's no good. Instead, we're going to start numbering here. 1, 2. If we go this way, it'd be 1, 2, 3, 4, 5. If we go to the left, it'd be 1, 2, 3, 4, 5, 6. We go to the left, so we have our longest chain that includes the double bond. Alright? So the parent word here, the parent chain here is hexene. And at the 2 position, we have a 1, 2, 3 propyl substituent. Okay? So it's 1, 2, 3, yes. So it's 2 propyl, okay, 2 propyl hexene. Okay, 2 propyl hexene. Is that correct? We better make sure we go ahead and put a 1 in there so that we let everybody know exactly where the double bond is. So 2 propyl, 1 hexene. Not too bad, right? Okay. So now the next thing is remember a double bond can be in cis configuration or trans. We've got to let everyone know if it's cis or trans. So we indicate cis or trans as well. Okay. Indicate cis or trans as well. For example, if we were to name this compound, the first thing we can determine is that double bond cis or trans. The 2 hydrogens are both on the same side of the double bond, so it's cis. You're going to put that out in the very front. Cis. And now we'll name it just like normal. We find our longest our longest chain that includes the double bond. Okay, so we can number 1, 2, 3, 4, 5, or we could do 1, 2, 3, 4, 5. Starting from the left, our double bond starts at carbon 2. Starting from the right, it's carbon 3. We want the lowest number we can get for our alkenes, so it's 1, 2, 3, 4, 5. Okay. So it would just be cis 2 pentene. Cis 2 pentene. All right. Now, remember, if you had 2 methyl substituents on an alkane, you would say 3,3-dimethyl or 2,4-dimethyl. We do the same thing with compounds that contain 2 double bonds. We call them dienes. Okay. Compounds with 2 double bonds are called dienes. Maybe a better example or analogy would be with alcohols. Since alcohols were functional groups instead of substituents, we called those diols. Okay. So what we do here is we drop the Ne off of our alkene name, we change it to diene. It's that simple. That's simple. So here's one right here. Name this. Name this. We got to start numbering. We can start numbering on the left side or start numbering on the right side. If we start on the left, our first double bond is carbon number 1. You can't get any better than that, so that's where you start. 1, 2, 3, 4, 5, 6, 7, 8. So it's a diene with 8 carbons. We have to indicate the position of the double bond. There's 1 and then carbon 5. So it's 1, 5 octadiene. 1, 5 octadiene. Okay, let's keep going. Let's add other substituents now. So name this. Name this. If we start from the right, we have 1, 2 at carbon 2. There's a methyl substituent. 3, 4, 5, 6. We can start from the left and have 1, 2. Let me change this. Sorry. No, that's good. That's good. 1, 2, 3, 4, 5, 6. Okay. So we either have 2 methyl, or we can choose the number from the left-hand side and put the alkene as carbon 2. The double bond trumps the substituent. Okay? So double bond gets priority, okay, in numbering over substituents. Double bond gets priority in numbering over substituents. Because of that, we start our numbering here. So our alkene starts at carbon 2. Our longest chain has 6 carbons, so it's hexene. We have a methyl substituent at the 5 position. So it's going to be 5 methyl, okay, 2 hexene. Let's try another one. Let's try another one. Name this. We got to determine where to start our numbering. It gives us the longest chain possible that has the alkene in it. We start from the left. 1, 2, 3. We got a 3-chloro and a 4 where the double bond is. Or we start from the right. 1, 2, 3. What determines this is where do we get to the alkene first? 1, 2, 3 here versus 1, 2, 3, 4 there. Remember, the alkene gets priority in numbering over the chlorine. So we're going to number from the right-hand side. 1, 2, 3, 4, 5, 6, and 7. Okay. So we know we have 2-methyl, 5-chloro. Okay, 2-methyl and 5-chloro with the double bond starting at carbon 3. So alphabetically it's 5-chloro, 2-methyl, okay, 3 with 7, so it's heptene. Are we done? Are we done? What kind of double bond do we have here? Draw your hydrogens out. We've got one sticking down. You've got one going up. They're on opposite sides, so it's a trans double bond. We need to specify. Trans, 5-chloro, 2-methyl, 3-heptene. Okay, let's move to cyclic alkenes now. Cyclic alkenes. They always, cyclic or cyclic alkenes always, okay, have the alkene at carbons 1 and 2. Have double bond at carbons 1 and 2. Okay, cyclic alkenes have the double bond at carbons 1 and 2. Okay. Example, if you were given this cyclohexene compound to name. Looks pretty complicated. We know that either this carbon or this carbon is going to be carbon number 1. Our numbering has to go through the double bond. So if we start here with carbon number 1, carbon number 2 has to be here. And then 3, 4, 5, 6. Numbering that way. Our first substituent is carbon number 4. Let's number it the other way. And compare. If we start carbon number 1 here, 1, 2, 3, 4, 5, 6. Our first substituent, the bromo group, is at carbon number 3. Over here, our first substituent was number 4. 3 is lower than 4, so that's the way we go. So now we will name it. Okay. It's 3-bromo, 4-methyl, 5-ethyl. Putting it alphabetically, 3-bromo, 5-ethyl, running out of room, 4-methyl, okay, 4-methyl what? Since our cyclic alkenes have the double bond at carbons 1 and 2, we don't have to specify. We don't have to say 1. It's understood. So we just simply put cyclohexene. Okay, 3-bromo, 5-ethyl, 4-methyl, cyclohexene.